Hey all, thanks for coming here. I'm Kristi Nikolla. My official title is written up there, but I've been working with the MOC since 2015. I was an intern back then, and I had the task of deploying our first production OpenStack cloud. That's an insane task, but thank you. I guess it worked out. I'm here talking about it, and since then I've served as the chair of the OpenStack Technical Committee, and I've also served as the project team lead for the OpenStack Identity Service, which is called Keystone, and a lot of the contributions and lessons that we've learned along the years have flown back to the upstream community, and especially in Keystone. So what does it take to provide a cloud service? Like, you'd think that you have just deployed your OpenStack or your OpenShift and you're done, right? But no, you have to allow users to sign up, advertise the services available, allow users to request access, allow users to grant access to other users, invoice based on usage, give support when users need it, have visibility into the inner workings of an open cloud, because that's one of our goals and it's very important for us, and quickly scale this up or down as demand grows or shrinks. And at this point, you're probably screaming internally, like, help. So that's what I mean by foundational services, and I'm going to talk about more in this presentation. So I'm not talking about OpenStack, OpenShift, Cloud Lab, Dataverse. I'm just talking about the services that make it possible for an open cloud, or any cloud, honestly, to offer these services to their users. So in a way, you can think of this as the infrastructure for the infrastructure. So they can be broadly categorized into identity and access management, so user registration and authentication, and project and allocation management. Then there's a consumption-based billing, telemetry, and I will be focusing and talking about these first three, but there's also support and facilitation, and you heard Wayne talk a bit about that yesterday, and bare metal provisioning, and you're going to hear that in the next two talks. So let's dive right in. Identity management. So we want to enable users to use one single identity across the services of the open cloud. We need to support them authenticating using their institutional credentials, but we also want to allow enterprise users to authenticate into the open cloud. To achieve this, we're using Keycloak. It's an open source identity provider. It supports OpenID Connect, which is an open standard for authentication. And it's what we are exposing as the interface to the services that are going to be and that are part of the open cloud. Both OpenStack and OpenShift support OpenID Connect, and if you're using the NERC today, that's what you're using to authenticate. And if an application that wants to join the open cloud doesn't support OpenID Connect, well, it should. So we've paired that up with CI Logon. CI Logon supports over 5,000 identity providers, including campus identity providers, GitHub, Google, Microsoft, and Orchid. CI Logon is operated by the National Center for Supercomputing Applications at the University of Illinois. So the above combinations make this possible. So you can see OpenStack and OpenShift up on the screen, and they both present an option for authenticating via OpenID Connect. And our project and allocation management, which is shown at the bottom, also supports logging in with OpenID Connect. So once a user clicks there, they are presented with a selection based on which university they're at. And if you are, as me, a BU affiliate, then you're going to see the familiar BU login screen. Hopefully you remember the password. And after that, you're going to be allowed in, and you can make use of the services. So, but authenticating is obviously not enough. There's access management, which is the second piece of identity and access management. So we need a way for PIs to see which cloud services are available and request access to them. We've implemented this functionality on top of an open source software called Coldfront, which is developed by the Center for Computational Research at the University of Buffalo. We've developed an open source Coldfront plugins that implement support for both OpenStack and OpenShift. We've also implemented a plugin that provides a REST API interface, which we've made heavy use of, especially for registering huge amounts of users for the classes. And all of this functionality is open source, and you can make use of it. So how does this work? PIs can create projects. They can grant access to other users or delegate management responsibilities to this project. Once they have a project, they can also request access to the cloud platforms and services that we make available. We define this level of access as an allocation. So ColdFront and the plugins that we have developed handle responsibilities for creating the required access control permissions so that the PI and its users have, say, a project in OpenShift or a namespace in a project in OpenStack or a namespace in OpenShift and are able to authenticate there and make use of these resources. It also deals with quota and limits and like sets the baseline for how much of the resources that we have available you can consume. And a project may have multiple allocations on multiple services, or it may have the same allocation, multiple allocations on the same service. And user memberships to these allocations is separate and managed by the PI or the user to which they have delegated this responsibility to. So here we see a view of what requesting access looks like. So there's a text box for the justification for why you're requiring access. There's a drop-down providing a listing of all of the services that we provide. Right now, it's only OpenStack and OpenShift that is available through ColdFront. And this is a view of an example project. So it contains 2 people there. You can see the role that each of the members have. And there are 2 allocations there which are expired. So this is a test project, but this is the view that PIs will be presented with, and it's fairly easy to use, and we've had good feedback. So great, now we've got people having access to the cloud services. It's time to make them pay. I think you've got away with it long enough. So we've implemented a pipeline for doing this so that each PI gets an invoice for the resources they have consumed in each of the allocations that they are using. So this is on a consumption-based. We've needed to define what's the fundamental unit for which we're going to be billing for, and that's the service unit. So we've defined what a service unit is for each of the services that we're providing. So for example, an OpenStack CPU-based VM has like 1 vCPU and 4 gigabytes of RAM, and that's a service unit. If your VM has 2 vCPUs and 8 gigs of RAM, it's going to be charged for 2 service units. And if you're using a GPU, you're going to be charged for 1 GPU service unit, either for OpenStack or OpenShift, and the same for storage on the gigabyte level. So finally, we've implemented tooling to collect that information, additions, multiplications, simple math, and each PI gets an invoice based on what they are using in the cloud. So it's also important to have visibility into the inner workings of anything that you're operating. That may be a simple Python application, but it's probably even more important when you're operating a big cloud. So we're collecting metrics and logs using Prometheus and Loki. And we're using Thanos for aggregating this information and storing it long term. And we're using Victoria metrics for storing this even more efficiently and even more longer term, probably until Ragnarok. Finally, Grafana is used to build shiny dashboards in a way that allows us to transform the data into something that we can gain information and insights from and we can action upon. So we're currently collecting this data on both OpenStack and OpenShift, although only the NERC OpenShift data is flowing into Thanos for long-term storage. And here's a diagram with a lot of arrows and boxes, as most service or microservice architectures tend to be. But fundamentally, we're getting most of these components through the Red Hat Advanced Cluster Management, and especially its observability service. So each of the clusters has a Prometheus and metrics collector, and the information flows into Thanos. So we can now use this data to see how students are doing. We had a heavy influx of students. And this is a graph of student use of OpenShift AI for classes. You can see a max of 327 containers, so it seems we're doing pretty good. And we can try to gain more insights. For example, this is a graph showing the change in consumption of resources. So you can see the spikes of usage. and when they happen, so we can make sure we're prepared for the inflow or cleaning up after the students. And if you're too lazy to go to Grafana, well, we'll find you on Slack. So you can get alerts like this on a daily basis. But our vision is to enable an open cloud, so a multi-sided open cloud with multiple participants across organizational boundaries. So we want people to start offering services in the open cloud, and we want them to plug into the open integration points that we're providing in authentication, allocation management, and telemetry. So all of these interfaces are open to anyone, and they are standard. So there's OpenID Connect, there's SCIM, there's Prometheus. And we want to encourage a collaborative environment rather than an adversarial one. So through this, we want to increase the pace of innovation that is possible with open source, but not only open source. So we want to shorten the time that it takes for code to make it from the developer's machine to the cloud, where a specialized or experimental service can be provided and gain access to scale or to specialized hardware deployed by hardware vendors. For example, we had Lenovo stand-up racks of hardware on our data centers. So this is becoming a reality now, and participants in the open cloud will have access to these specialized resources, and researchers can make experiments using specialized hardware and even offer back experimental services. So this really makes the feedback loop that Oran described yesterday possible, finally. And we also want other data centers to join us in the open cloud, but I'm an open source engineer at heart. I want all of this to be reproducible. I want all of this to be open source. Probably Oran will get upset about this, but I am an open source engineer. So everything we're doing is open source. You can use our work. You can create your own open cloud. There is no secret sauce here. All of the code, Kubernetes manifests, container files, Ansible playbooks, all of the tooling is available. And finally, what's missing? Well, we want to make telemetry data more available to PIs and users for the resources that they're consuming, but also to researchers. And we also want to collect more data, so from more systems. That's part of our vision. We also, we're currently building users once a month, but we want to be able to allow showback and reporting so that PIs can see usage on a real-time basis of the resources that they're using. Another thing we've started to think about is direct billing to users. Currently, everything flows through the institutions, so we have no ability to directly bill users for usage in the open cloud. Well, what else? We'll see. We're going to find out as you join us, and we build this cloud together. Thank you. Any questions?
So I've been actually using the system to run 3 research projects, and I have to say one of the key properties that I found has been great has been the adherence to APIs that let me write my own scripts, and I'm not bound to any particular interfaces. I know how to write my own scripts, and I've been able to automate both the use of our GPU systems and our non-GPU systems for our work, which has been fantastic, and also I've been really happy with the ability to allocate storage, and right now your pricing model for me has been fantastic, which has been, you haven't created a bill for me, so I'm thrilled with that too. But just something that you mentioned towards the end that I think is really super critical, so just want to add my voice to the need for it. I really want those interfaces so that my scripts will automatically know what my current account charge is and automatically throttle whether I'm going to let my sub-users go. Because that's the other thing that I found very powerful. The stuff we've done, all my students and my researchers do not know about any of this, right? I've hooked it up so that I played a little bit of SSH magic, they SSH, all of a sudden for them, the SSH all of a sudden stops and says, oh, I'm sorry. Wait a couple of seconds and the machine will be ready for you. The machine comes up, they're in. But I don't want them in if my account is running low. So those interfaces would be really important to me.
You get it.
Okay.
So how hard is it to do congestion pricing? And how much can be exposed? Can I say I want to run my job only at 9 a.m. when no one else is running?
So the building blocks are there. It's just a matter of assembling all of them together. Because if we're collecting the telemetry and we see when the spikes of usage are, then it seems reasonable that we are able to do that. It's just making it a priority, putting the work to get it done, and doing it.
One of the problems is that allocating VM resources is sticky. Once you get the damn thing set up, you want to keep it going. And so how do you like roll or back up or roll off a VM so that it doesn't actually take up any resources, but you still have it around for when your allocation of billing is now coming together?
So for OpenStack, if you're booting from a volume, then you can like delete the instance and preserve the data in the volume, and then the next time around you can spin up another instance. We're pretty cheap on on our storage level, so I think that should be the way to go, putting the data in storage and then spinning that up again.
A question about carbon footprint. We have more and more projects where we kind of need to instrument how much power we are using, and I'm wondering if in Prometheus you have ways of adding sensors to report on power usage and eventually also temperatures inside the machines, to have an insight on how much cooling has been used for matching the power.
I do not have information for that right now. Perhaps Thorsten does.
It's not yet included. Sorry. It's not yet included, at least not on my side, but I would love to have this, so it's in a plan, yes. We will have it. We will have it. The plan was like it's not there yet, so yeah, it's a definitely plan. It's a must.
So you get it too.
So I have one question, Kristi. One thing I expected you to talk about is the cultural aspect between the open source community, what hasn't been happening, what you. Can you talk to that at all? You know what I'm talking about.
Yeah, so I mean that's part of the feedback loop that I'm describing here. It takes a long time from submitting code upstream to having it actually in use in your data center, solving the problem for which you contributed it upstream, and like that's really stifling the desire on my part to like make contributions just based on how long it will take for that to come back to me. And on a similar level, there's no way for us to get the same level of either information or users or and I'm talking about me with my open source community hat here, not like my MOC engineering hat, but like having access to a large pool of users that is not locked into a walled garden with high egress costs, and like not giving you the information of how the users are using your services, and it makes it really hard for you to like stand up any experimental services to try and figure out what works and what doesn't, or even worse, like stealing that information from you and providing a competing service like Amazon has done a lot of times. So like we want to create a level playing field where everyone can can like try their hand at innovation, be them a small scale, be them one singular engineer, be them a larger company. It's just really powerful to give that sort of access to the level of users that we have, and having those integration points where we have done the heavy lifting for you, and you can just come here and give us a rack of hardware or give us your endpoint for authentication, and we're going to deal with the rest. And we're going to give you a bill for your users. You don't have to think about it.
We have one more question over here.
Hey, just a quick question about the identities. So Jonathan mentioned, he does some SSH key machination on his own. How do you have to have a common identity scheme and kind of system in order to deal with sub-users and actual users and kind of end users? Is there a lot of complexity there, or you found you can just delegate it to the PIs or whatever?
So in this case, Jonathan was talking about like the authorized keys in a VM. We don't deal with that. We're mostly talking about the API level or the dashboard level, like where you are able to authenticate into the cloud and spin up new VMs or other VMs. If your users are getting direct access to the VM through an SSH key, we don't see that level of permissions. Like, you're free to do whatever you want with that. It goes, like, it bypasses us in a way. So our authentication level is at the API, and it's using OpenID Connect. You can do what you want.
We have another question from the live stream. Dwayne Branch is asking, are serverless applications possible?
They are, and I think we are investigating whatever OpenShift provides for serverless. So we're perhaps going to have more information soon about that. But I know that we are experimenting with offering function as a service on top of OpenShift.
I have one here. Are we open to the next question? I have a question here, and I'm sorry if I interrupted something there. I just I grabbed the mic. I'm Doug Berry from Lenovo, and my question relates to demand, because one of the things we're doing with the MOC is to provide hardware as demanded. There seems to be a lot of GPU interest in the community across the board. We just installed 64 A100s for the MOC's use, and it's being turned up here shortly. But I'm kind of looking to query the crowd. We're looking to try and get H100s into your cloud too, and I'm just trying to gauge, is that of interest, and how much interest? Because it is very interesting across the world. They're kind of hard to get. But if we were able to provide those, would you be able to use them? Because we're trying to gauge what's next and get ahead of demand. So I'm kind of polling the room here. Is H100 very interesting to you for that?
Lift your hand if it is.
Okay. And remember, we have A100s there today. They're turning them on now. I don't know if the access time, but they're in there. So we'll work to get H100s for you too.
Yay.
To that point, if we're going to make those, so right now I'm using one of the A100s. We do have to have a better understanding of the cost model there, right? Like, those are expensive for me, and yet right now the basic model is if I own the VM, I get paid for it as long as I own the VM. But so it's actually 2 points. One, to the authentication issue. So what we do to manage that, it's not actually just the SSH keys we're doing. So I, as a PI, have chosen to get a key. So, the standard thing is I download one of their certs, strings, and then I have embedded in my own scripts that then I hand a secret to my users. That then lets them, on demand, spin the VM up, but then they use their own key to go into the VM. But I, as a PI, have decided to go with that model. And I'm very careful not to let the secret for the CloudFront my CloudFront API access point leak beyond my users. But that's just a choice how we chose to do it rather than authenticate each one with their own CloudFront key.
By the way, Tara, was there any response online about people that wanted the GPUs?
You had the right diagram up a second ago. So when you're doing the systems research, how does the infrastructure get partitioned so that there are parts of it that are under development, parts of it that are under testing, and then parts of it that are going to be production, so that people who can actually are getting billed for it aren't going to get screwed when you add a new feature into the system? And how do you do that I don't know, development life cycle in the current version?
So it depends on the kind of system research. If it requires bare metal, you're going to hear about that in the next talk, where we talk about bare metal provisioning. But yeah.
We have test clusters. Red Hat sponsors test clusters. So if you're doing actual systems research and you're coming in and working on a new systems capability, you're not going to be charged at the maximum rate off the bat to experiment. So, obviously there's a limit to how much of that we can do, but it's recognized in the OpenShift environment. We can build your own cluster for that kind of experimentation. Obviously not 1,000 server cluster, but, and in the bare metal cluster, we're going to have a whole talk about that piece. In the OpenStack, it's a little more complicated. But at least for sure in the bare metal and in OpenShift, you can do that.
So I have a question about, I guess, I haven't really tracked the latest in OpenStack and OpenShift on this front, but something that draws people to public cloud, the major public cloud providers a lot, is data warehouse technology. So things like BigQuery and Redshift and Snowflake and so forth. I'm wondering, what are the options available in OpenStack, OpenShift, this kind of stack? And will MOC have a sort of data warehouse equivalent to those technologies at some point in the future, or does it already even?
So right now we're using the NERC for storage, so it is possible to make use of the NERC offerings or spin up other offerings on top of NERC. So you heard yesterday talk about Dataverse and how it can access data sets directly from NERC. And if you want to stand up a new data warehousing technology and integrate into our integration points, then you are going to appear in the dropdown and users are going to be able to use you. We're just starting out now, so we have S3 through the OpenStack service and access to the NERC Ceph. So that's what we have right now, but this is this is changing on a daily basis. A lot of exciting announcements yesterday and today, and it's hard to keep track of everything. So, great question.